first responders pack. In this top pocket here will be all your equipment required for taking vitals. So you'll have your stethoscope, you will have scissors, a pupil torch, 2 types of blood pressure cufflinks, adult and pediatric. You'll have your blood glucose kit, like to take blood glucose levels, and you also have your thermometer and temperature equipment in there. In the pocket below it here, there is a paramedics medical module within the St. John's one. In this pocket here is trauma and hemorrhage control. So we've got a tourniquet, and we've got 2 of these because in case the bleeding is really excessive or in case one doesn't work, so we always have 2. We have various types of bandages. So we've got bandages, we've got triangle bandages, various types of wounds and gauzes, tears. We've got some tape, we've got some saline fluids, so that's just to sterilise and clean the wounds, and we've also got some steri strips and just bleeding control, stuff like that. In this top pocket here, we have all of your personal safety equipment. So there's some glasses, emesis bags, and we've got some numbing spray, and there's also a strap to help with the C-spine neck brace. Yep, and that's everything in that pocket. This pocket here is your diabetes control kit. So you've got a draw-up syringe, you'll have IV glucose, you've got your glucagon kit in here, glucagon kit, and you've also got oral glucose as well. In this main pocket now, you'll notice compared to the St. John's First Responders pack, this one only has 2 pockets instead of 3, so the top 2 just combine into this one. So in this pocket we have our airway management, so we have our OPAs, our MPAs, and we also have lubricant for the MPAs. We also have laryngoscope in here. Here we have forceps to remove foreign material in case someone was choking or something like that. We have methoxyfluorine, also known as the green whistle. We have specimen bags, or just to keep sterilised equipment, rubbish out. We also have our oral medication, so we have Panadol, ibuprofen, and tramadol. That's all located in there. So usually in the First Responders pack, those would be separated. In here, we have our airway medications. So we have a nebulizer mask, we have an adult and a pediatric one, and we also have airway tubing as well. And we also have our airway medications. So if we open this up and have a look, we will see we have 2 packets of adrenaline, we've got some salbutamol, and we've also got some ibuprofen in here. And that's all the airway medication. Moving to this pocket here, we have a towel. We have our sharps container and kit. We have all the stuff required for IVs, so we've just got some fluids here. We've got our slippery Sam sheets or sliding sheets. We will have a cardboard splint here. We've got our neck brace here. We have our IV kit here, so we can just open this up and we can just see all the backup and necessities required for an IV. In here we have our mates, just all the equipment in there. And we have our pediatric and our adult BVM masks in these 2 pockets here. And in here they just contain the basics such as a reservoir bag, just mask, peak valve, filter, tube. So this is our LSU suction unit, and to do a test of this at the beginning of each shift, we hold down our test button and turn the power on fully. We hold this until the green light goes to the second bar, and then we fully include the patient tubing, and we can see the green light heading up here. And we hold this until it makes no noise, and then we can depressurize it like so. The components of the suction unit include the rigid catheter or the Yankoa handle. We also have an option of a soft catheter, which we used in pediatrics or if you're mobile in the ambulance. We have our patient tubing, we have our vacuum tubing, and we have our reusable canister. We use suction if the patient's airway mouth has been occluded with fluids or if they have a decreased GCS. And when we're suctioning, we have the patient in the recovery position, and this is because so no fluids occlude the patient's airway, and that gravity can just allow fluids to come out of the mouth naturally. So to suction, we turn on the unit, we place the catheter in the mouth only as far as visible, and then to start the suctioning, we place our index finger on this hole here, and then we suction in a circular motion only on the way out for no more than 10 seconds. And then complications involved in suctioning include induced vomiting, induced bradycardia, aspirations, hypoxia, and trauma to the mouth. So here we have oxygen delivery, and this is our oxygen air, and we can tell this is our oxygen air bottle as it's got a white neck of the bottle compared to our medical air, which would be black. Here we have our regulator, and within the regulator we have something called the Bodak seal, which we can take off and check at the beginning of each shift to ensure that there are no cracks within this, as it creates a seal so that no air can escape. Now to attach the regulator onto the bottle, we just line up the prongs like that, and then we just turn this until it tightens like that. And now to turn on the bottle, we turn this knob here, and we can see that our flow rates now, they're just below 1000 psi. Indications for oxygen delivery would be if SpO2 rates were below 94%. Also if there was a TBI, carbon monoxide poisoning, decompression illness, respiratory distress, and shock or an airway obstruction. And so we've got these nasal prongs here, and these get set to 4 on our bottle. So we're just going to attach these, and we'll turn this to 4. And we can put these on our patient just by inserting these into the nostrils, putting these behind the ears, like so, and then just using this to tighten it around the chin. And once again, this is set to 4. And now to turn off our air, we simply turn the knob, like so, and we depressurize this by we'll take this off and then just until it goes to 0, and then we can take the regulator off again, like so. This is our LifePak 15. In here we have our defib pads, which are always plugged in and connected to the monitor at all times. In here we have our 12 lead ECG, we have our cardiac drugs, which include aspirin, GTN spray and a razor, and it is vital to check the expiration dates of these at the beginning of each shift. If they expired, then just simply replace them. Here we have our test shock box. Over here we have our 3 lead ECG, which always has electrodes attached to it, and it plugs in here. And here we have spare roll for the machine. In the back here we have our end-tidal CO2, which connects in here. We also have our SpO2, which connects in here. In the back here we have our blood pressure cufflinks. We have our bariatric, pediatric and adult size cufflink. We also have spare electrodes and spare defib pads. To check the batteries of the LifePak, we simply remove this like this. We press both buttons, and if we want to replace the battery, we push that in like that, take it out, and then simply replace it by clicking it back in. We also have our paper roll, and if we need to replace this, we just lift this flap here, pull it out, and then just take the roll out like this, and then to replace it, simply put it in back like that with the new roll and click it back in. Turn this on, we press the green on button and just hold that for a couple of seconds. When we first turn it on, it will automatically go into AED mode.
Push analyze.
But to turn this into manual mode, we just press lead. And to do a user test, we go options, and then we use the dial until it goes to user test, and we press enter by pressing the button in, and it'll print a user test. It is important to do a user test at the beginning of each shift, as it tells us and ensures us whether the monitor is safe and ready to use on the road. If it's not, then we can't go out, and we either need to replace the monitor or that vehicle cannot go out. So it's printing the user test, and as you can see, user test passed. From here we can test the shock by using our shock box. So we can go energy select, enter manual mode, yes. The amount of joules, we want to go down to 50 because it's just a test. When we go charge, it's charging. To deliver the shock, we just press the shock button. Energy delivered. We want to charge this again, and this time we want to cancel the shock. We press the enter button on the knob there. To go back into AED mode from manual mode, we just press the button analyze.
Analyzing now. Stand
and it will
clear.
do all the types of things that a normal AED
No
will
shock
do.
advised. Start CPR.
So to go back into manual mode, we just press lead. And with our metronome here, it is at 100 beats per minute, which does not correlate to the new high performance CPR standards, which is 110 beats per minute. We can change the volume of the metronome by going options, alarm volume, and then louder, quieter, and to turn it back off we just go CPR and stop metronome. We can also turn this into day and night mode by pressing this button here. So white screen, black screen, white screen, black screen. We also have our non-invasive blood pressure button, which we would use if we want to take a blood pressure on the patient. Now we will attach the 3 lead ECG. I already have my electrodes attached to me. So here we have our right arm, We have our right leg. We have our left leg. And we have our left arm. I think this one came off. And you can see my wave being displayed on the screen. If we want to change the size of the wave, we can just go size and then use the dial to select the size we like, bigger, or we can also use the dial until it highlights the wave, press enter, use the dial size to select the size we would like to use. With this, we would also take our patient's pulse, radial pulse, for 15 seconds. We would then multiply this by 4, and this pulse should correlate as to what is being displayed on our monitor. We also have our SpO2, and so this just goes on the patient's index finger. The SpO2 is significant as it calculates the percentage of oxygen that is attached to the hemoglobin within the blood. This is also significant because if our patient's SpO2 percentage was below 94, this would indicate that they do require oxygen, and the number of the percentage, the lower it is, the more oxygen they require, etc, etc. Now to print out one of my waves, I just press print, and if I want to stop printing, I just press print again and rip it off like this. We are able to change our lead views by pressing lead, and then we can turn the dial and select which lead view we would like to view. We can also change our heart rate volume by turning the dial until we go to QRS volume, turn the dial higher, lower, and with our non-invasive blood pressure, we can also change the intervals for that, just like so, by using the dial. So this is our BVM, and we use this with patients who are bradypnea with less than 12 breaths per minute, who are also poorly perfused. With a cardiac arrest, our ventilation rate would be 8 to 10 BPM, and with a non-cardiac arrest it would be 10 to 12. We can test the components of our BVM by placing our hands over this and squeezing the bag. If there is resistance, we can tell that there's no air leaking. We can also place our reservoir bag over and inflate it. If it inflates sufficiently and there's no air leaking from it, we can tell that it's sufficient to use. With our BVM, so we have our reservoir bag, we have our BVM chamber, our PEEP valve, and with our PEEP valve, we do not use this if a patient is in cardiac arrest or also has pneumothorax. But we do use this for all other purposes requiring ventilation, such as pulmonary edema. We also have our filter, which goes on like so, and our mask itself. We also have our airway tubing, and the other end of this would just connect to the oxygen bottle, and the flow rate is 10 to 15 litres per minute. So we have our single-handed ventilation, so we have our CE grip with one hand on the bag. We also have our double-handed grip with our partner who would be doing ventilations for us. We ventilate in the rule of threes, so we squeeze a third of the bag with 3 fingers and we ventilate within 3 seconds. Our complications is barotrauma, gastric inflation, and overinflation of the lungs. Factors to consider is our MOANS acronym, so our mask seal, so for example if a patient had a beard, obesity / obstruction, age, no teeth / neck mobility, stiffness / snores. So this is airway management, and we have 4 positions that we can put our patient in to help manage the airway. We have our head tilt and chin lift, we have our jaw thrust, we have our sniffers position, where we place a towel under the base of the head, which gives flexion of the neck and extension of the head, and we have our recovery position, which just allows no fluid to occlude the patient's airway. We have our MPA, and to measure this, we measure this from the nostril to the base of the mandible or the bottom of the earlobe, and to insert this we lube it up with MPA lubricant, and we just insert it into the patient's nostril like so. Indications for using an MPA would be GCs of below 8, a situation where OPA would be inappropriate to use. incomprehensible to sounds of pain. Contradictions with a MPA would be a TBI or a basal skull fracture, for example. Complications is nosebleeds or polyps. With our OPA, we can measure this up by going from the side of the mouth to the base of the mandible, and we insert this by inserting it upright at first, and then we rotate it 180 degrees and finish inserting it into the patient like so. Indications for this would be a GCS of 8 or below, a motor score of below 6, incomprehensible to sounds of pain. Contraindications would be the gag reflex would be intact, and complications would be emesis, the OPA being too big or too small, induced vomiting, and trauma to the oropharynx.